Hello students, welcome back to my YouTube channel Sriram Devarajan. Today in this video I am going to discuss exercise 7.6 problem number 7th one. I already solved problem number 1 to 6. It is available in my YouTube channel Sriram Devarajan. You just check it out in the playlist. Today in this discussion the problem 7, it is given as you have to integrate x sine inverse of x dx. Because of we have two function, one is x, another one is sine inverse of x, we have to use method of integration by parts. We have already seen method of substitution, method of partial fraction in this exercise 7.6. all the problems mostly based on integration by parts. If you apply integration by parts, you must know isolate. It is a shortcut method for choosing u and also integral dv. Here x is there, algebraic, sine inverse of x is there, that is inverse. Inverse comes first, therefore choose u as sine inverse of x. Solution. And integral dv integral x dx. This part differentiation, this part integration. Find du by dx. Answer is 1 by root of 1 minus x square. This is derivative of sine inverse of x. What is du? dx by root of 1 minus x square. From this side we have to do integration. Integral dv is v, integration of x dx from the formula it is x square by 2 uv v du. This is formula for integration by parts for finding u dv, which is equal to uv x square sine inverse of x by 2 minus integral v du x square by 2. What is du? dx by root of 1 minus x square. X square sine inverse of x by 2 minus 1 by 2 integral x square dx by root of 1 minus x square. See, in the denominator we have 1 minus x square. I am going to rewrite the x square as plus 1 by 2 minus x square. X square sine inverse of x by 2 plus 1 by 2. I am going to add 1 and subtract 1 divided by root of 1 minus x square dx. For this part I am taking it as equation 1. In 1 we have 1 by 2 integral 1 minus x square minus 1 divided by root of 1 minus x square dx. This can be further written as 1 by 2 1 minus x square integral divided by root of 1 minus x square into dx. Another one minus integral dx by root of 1 minus x square. I am multiplying these two. Another one 1 into dx. 1 by 2 integral 1 minus x square can be written as 1 minus x square into root of 1 minus x square divided by root of 1 minus x square dx minus integral dx by root of 1 minus x square. x can be written as root x into root x. These two will get cancelled. Remaining term 1 by 2 integral root of 1 minus x square dx minus integral dx by root of 1 minus x square. We have to apply the formula for this one and for this one. I am going to use this formula for integral root of 1 minus x square dx. Here a is 1, that is we can write this 1 as 1 square. A square means 1 square. Therefore, one by 2 for this part, x by 2 root of 1 minus x square plus 1 by 2 sine inverse of x minus sine inverse of x for this part. Straight away we have the formula integral dx by root of integral dx by root of 1 minus x square is sine inverse of x. For this part, apply the formula, we are getting sine inverse of x. For integral root of 1 minus x square, I am applying the formula x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a for integral root of 1 minus x square. Write this equation as 2, substitute 2 in 1. 1 implies first term x square by 2 sine inverse of x plus 1 by 2 into x by 2, that is x by 4 root of 1 minus x square plus 1 by 4 sine inverse of x (1 by 2) is common to x this term and also this term and also for this term. Last term minus 1 by 2 sine inverse of x. I am multiplying 1 by 2 with x by 2, 1 by 2 with 1 by 2, 1 by 2 minus sine inverse of x. This is the final answer. Here sine inverse of x, sine inverse of x, sine inverse of x. Take sine inverse of x outside, x square by 2 plus 1 by 4 minus 1 by 2, remaining term x by 4 root of 1 minus x square, write and plus c because integration is over, and also you put plus c. Sine inverse of x, LCM is 4, 2x square plus 1 minus 2 plus x by 4 root of 1 minus x square plus c. Answer is sine inverse of x 2x square minus 1 by 4 plus x by 4 root of 1 minus x square plus c. This is the answer for the problem integral x sine inverse of x. Answer is sine inverse of x into 2x square minus 1 by 4 plus x by 4 root of 1 minus x square plus c for the problem number 7. Now I am going to proceed the next problem, problem number 8. Problem number 8, integral x tan inverse of x dx. Again we have two functions, one is x, another is tan inverse of x. Apply integration by parts with the help of shortcut tricks. Isolate. Here inverse is there, that is tan inverse of x, and also algebraic is there, that is x. Isolate, inverse comes first, then algebraic. Solution: choose u tan inverse of x. Find derivative of u. 1 by 1 plus x square. What is du? dx by 1 plus x square. This is differentiation part. Now integration part. Find dv, integral x dx. Integration of dv is v. Integral x dx we know very well, x square by 2. Formula is uv minus integral v du. This is the formula for integration by parts. LHS we know u dv. Write u and v, tan inverse of x into x square by 2 minus v x square by 2 du dx by 1 plus x square. We can write it as x square tan inverse of x by 2 minus 1 by 2 integral x square dx by 1 plus x square. This is equation 1. From 1, what is 1? 1 by 2 integral x square dx by 1 plus x square can be written as 1 by 2. I am adding 1 and subtracting 1 because I need 1 plus x square in the numerator, so that integrations will be very easy. Therefore I am adding 1 and subtracting 1 into dx, which is equivalent to 1 by 2 integral x square plus 1 by 1 plus x square dx minus 1 by 2 integral dx by 1 plus x square. I am writing this one as one part, remaining 1 by 1 plus x square as another part. Find integration cancelling these two terms. 1 by 2 integral dx x minus 1 by 2 integration of dx by 1 plus x square tan inverse of x. This is equation 2 plus c. Substitute 2 in 1. 1 implies x square by 2 tan inverse of x. Already minus 1 by 2. I have taken already 1 by 2. Minus of, if you multiply by minus, answer is minus x by 2 minus into minus plus 1 by 2 tan inverse of x plus c. This is the answer for the problem number 8. I will continue the next problem in this video. Problem number 9. What is problem number 9? X cos inverse of x dx. Again we have two functions, apply integration by parts. One function is u, another one is cos inverse of x. Here inverse is present in this problem. Algebraic is x. With the help of isolate we can choose our u and dv. Inverse is there which comes first, therefore choose u as cos inverse of x, that is solution. Integral dv as integral x dx. This part differentiation, this part integration. Differentiation, integration, cos inverse of x. Find du by dx. Answer is minus 1 by root of 1 minus x square du minus dx by root of 1 minus x square. Differentiation part is over. Now I am going to do integration. Integral dv v, integration of x dx, x square by 2, formula uv minus integral v du. U is cos inverse of x, x square by 2 minus integral v is x square by 2 minus of dx by root of 1 minus x square. Answer is x square cos inverse of x by 2 minus x square in numerator. I need 1 minus x square in the numerator. Therefore add 1, subtract 1 divided by root of 1 minus x square dx. Take 2 outside, that is 1 by 2. This is our equation 1. Now what is 1? Minus 1 by 2, 1 minus x square minus 1 divided by root of 1 minus x square dx. Minus 1 by 2, I am writing in two parts. First part 1 minus x square dx divided by root of 1 minus x square plus 1 by 2 integral dx by root of 1 minus x square. Minus 1 by 2, I can write 1 minus x square as root of 1 minus x square into root of 1 minus x square divided by root of 1 minus x square dx plus last term 1 by 2 dx by root of 1 minus x square. These two will get cancelled. First part minus 1 by 2 root of 1 minus x square dx plus 1 by 2 integral dx by root of 1 minus x square. Already in the previous problem we are writing the formula for the first part. Root of a square minus x square dx in integration, the formula is x by 2 root of 1 minus x square a square by 2 1 by 2 sine inverse of x plus 1 by 2 sine inverse of x plus c. Straight away from the formula for this part, here also the formula for integral root of a square minus x square dx. This is equation 2. Substitute 2 in 1. Therefore 1 implies first term x square by 2 cos inverse of x minus of means here minus half into x by 2 minus x by 4 root of 1 minus x square minus into plus minus 1 by 4 sine inverse of x minus 1 by 4 To simplify further, we know very well sine inverse of x plus cos inverse of x is pi by 2. What is cos inverse of x? Pi by 2 minus x. From the inverse trigonometry function chapter, we know very well one formula: sine inverse of x plus cos inverse of x equal to pi by 2. I am going to replace this sine inverse of x and this sine inverse of x in terms of cos inverse of x. Therefore, sine inverse of x equal to pi by 2 minus cos inverse of x, which is equal to x square by 2 cos inverse of x minus x by 4 root of 1 minus x square minus 1 by 4 pi by 2 minus cos inverse of x plus 1 by 2 pi by 2 minus cos inverse of x plus c. I am replacing this part and this part. Now simplify x square by 2 cos inverse of x minus x by 4 root of 1 minus x square minus pi by 8 plus cos inverse of x by 4 plus pi by 4 minus cos inverse of x by 2 plus c. I am taking cos inverse of x outside. First term x square by 2 plus 1 by 4. Last one minus 1 by 2. Remaining term minus x by 4 root of 1 minus x square, here minus pi by 8, here plus pi by 4, minus pi by 8 plus pi by 4 plus c. What is the final answer? Cos inverse of x, LCM is 4, 2x square plus 1 minus 2 minus x by 4 root of 1 minus x square. For this part, LCM is 8 minus pi plus 2 pi plus c. Final answer: cos inverse of x 2x square minus 1 by 4 minus x by 4 root of 1 minus x square minus pi plus 2 pi plus pi by 8 plus c. These two are constant, therefore take it as sum cap c. Therefore the answer is cos inverse of x 2x square minus 1 by 4 minus x by 4 root of 1 minus x square plus c. This is answer for the problem number 9. I will upload more problems from the 7.6 in the upcoming video. You just subscribe my channel, share my channel to your friend and like my channel. Thank you.